Basically, in order to compute the volume of this, we slice this object perpendicularly, parallel to the y-axis and perpendicular to the x-axis. We will find the red area here, which is an area, right? Then we take the integral from a to b with respect to the x variables. This will give us the volume of this object. Okay? We did this example. At each position of x, it will be a circle here. We compute the area of that circle with a given x, right? And according to this properties, x will run from negative r to r. Okay, very well. And here is called the washer, right, method. If a cross section is bounded by the inner circle and the outer circle, then we take the difference of these two areas, right? And again, it rotates. Okay. So integral of this guy, the similar problems here we did was integral from 0 to 1 of the area, each of them here. And similarly, if we compute the volume formed by this, y is equal to x cubed, y equal to 8, x is equal to 0, and y is, yeah, this region. Then this one we slice perpendicularly to y, because that way is easier. Okay? So the same story. We need to compute the area. If it rotates about the y-axis, it will create a circle here, right? Our job is to compute the area of this circle. And the area of this, at any point y0, y run from 0 to 8. If we're given at the y0, we can compute the x, the position, which is the radius of that one. The distance here, the point here should satisfy the equation y equal to x squared, x cubed. Therefore, we can compute x0, which is the radius of this one. Having the radius, then we can compute the area of this circle. Integral from y is equal to 0 to 8 gives us the volume of this object. Okay. The difficulty of these types of problems is to imagine, right? So when we do many problems, it will help to imagine better. So now let us play with some more examples. Okay? The region R, or let us call it D, enclosed by the curve y is equal to x and y is equal to x squared is rotated about the x-axis. Find the volume of the resulting solid. Okay. Again, we reading this question, we have no idea, right? We need to graph these curves and see how it looks like. Okay. First, we draw the curve y is equal to x. And we have done this many times in the chapter 5, right? Or the simplest way is to pick some special value. This is a linear line. At x is equal to 1, what is y? Yeah. This means okay, this is the line y is equal to x. And the second line at x is equal to 0, what is y? Yeah, 0. And at x is equal to 1, yeah, we have done this many times as well. Right? This is y is equal to x squared. So the region bounded by these lines is this guy. So now, if it rotated about the x-axis, right? So now we need to imagine there's no way. It's really hard to draw. But yeah, it would be rotating like this. And if it rotate, suppose we have a if it rotate up to this line, this is line y is equal to negative x, right? Then at each position here, let us cut it, right? Perpendicular to the x-axis. So at that plane, this forms a something like this, right? Okay. Do you all see it? So we need to compute the area of this guy, right? What is the radius of this guy? But be careful. Inside that, let me, yeah, oops. Inside that line, there is a inner circle. somehow like this, okay? And the point here, yeah, should be like this, okay? So the distance from the x-axis to the curve here, let us call it R inner, right? And the red, the outer circle is R out. Okay? Do you all see it? So here it means what is R in? If we are given at the point x0 right here, right? R in will be the distance from this point x0 to this point, okay? Which means we need to find this distance. And the point here belongs to the graph y is equal to x squared, right? And the distance here will be, what is it? Yeah, at 0 in terms of x0. X0 squared, right? Very good. Okay. And R out it will be very good. At the position x0, the R out will be x here, right? It means the area in, right? It will be pi R in square, right? Which is pi and then x0 square. Okay. How about the area of the outer circle? It will be pi and the outer one. Yeah, x0. Yeah, R out square, right? Oh, this is square and then square. Sorry. And below here is pi and x0 square. Do you all see it? Very good. This is what we see from the picture since we grab it. And we know it. The intersection of these two lines is at 0 and 1, right? Or we can find it algebraically, right? If we set f of x is g of x is x, g of x is the second curve is x squared. In order to find the intersection point, we solve f of x is equal to g of x, right? Or the same things, f of x minus g of x is equal to 0. Okay. So in this case, f of x is x. So we substitute this here. And what is g of x here? Yeah. We need to solve this to find the intersection point. So, therefore, we have yes. If you do x squared equal to x, as I mentioned yesterday, you may lose a solution. The best way is to factor the common factor out. In this case, x. So it will be x times 1 minus x is equal to 0, right? If you divide it by x, you may miss a point. Okay? Therefore, there are two cases. The first case is this, the product of two things. If their product is equal to 0, then the first guy should be 0, or the second guy should be 0. So be careful with this. Therefore, we have two solutions, x is equal to 0 or x is equal to 1. It makes sense, right? Here, these are the intersection according to the graph, okay? Now, if we make a table, we study how x and fx change from negative infinity to infinity. And there are two solutions of f and g, right? At 0 and 1. Okay. So let us call this function the function h of x is the difference of f and g. Okay. Now for x in this domain from 0 to infinity to 1, the function h is this guy. This is a quadratic function which has two solutions. Therefore, in the interval between these two solutions, the sign will be the opposite sign of the highest degree here. And the highest degree here, the parameter of that in front of that is -1. Therefore, inside this should be the opposite sign. It will be positive and negative. Because some of you did it pretty good here. Or you can simply study each cases of the function x and 1 minus x. Take the product, you get the same here. Okay? And this is the sign of h of x. Here, h of x is the difference of f and g, and it is negative. What does it mean? So f and g, which one is larger from the interval of negative infinity to 0? Yes, g is larger than x. Therefore, the difference of them would be negative. Same story. And here is the point here is g is equal to x, f, right? And here f will be larger than g. Therefore, the difference will be positive. And similarly, f is smaller than g, where in the interval from 1 to infinity. It makes sense here. See, in the graph here, the function f of x is this guy, right? And this guy is g of x is equal to x squared. From the interval from 0 to 1, f is larger than g, so it is on top of g here, right? Outside of that, we see that it happens differently. Okay, g is larger than f in this interval, negative infinity to 0, and the same story from intervals from 1 to infinity, g is larger than f. So everything makes sense, right? You can do either with a graph, or you can just make a table and find the intersection point here, study it, and do it here, right? Whichever way you prefer. But in the end, what we need to do is to take the integrals from 0 to 1, right? So the volume will be integral from the lower bound 0 to 1 of, with respect to the x coordinate, right? Of the difference of the inner and outer area. Okay. And according to the previous result, the outer one will be pi. So now, for x0, if it is a variable, so we just remove the not, and s out will be pi x squared, right? Minus pi and x square and square again, dx. Okay, so computing this integral is not difficult, right? So we find the antiderivative of each of them here. The constant is easy. So the antiderivative of this will be, we rewrite the constant. And looking for the antiderivative of x squared, it will be x squared, the antiderivative, so we add 1 to the power of that function. And then we multiply with a fraction where the denominator of this guy is the power here. So that when we take the derivative, these two will cancel each other. Okay? And similarly, minus pi. This is x to the 4th, right? So anyone help me here? Yes. And very good, right? So let's see. This is a definite integral, right? So it returns a number. So we need to evaluate this from x is equal to 0 to the upper limit x is equal to 1 here. Okay, be careful. The indefinite integral returns a families of functions. A definite integral returns the area of the curve under a function. So now let us simplify these. It be pi 1/3 of x cubed minus pi over 5 here, x to the 5 here, x at 0 and x at 1. Okay? Are we good? So now we need to evaluate the upper limit and lower limit. So Justin, can you help me with this guy? Can you see it? Austin, I'm sorry. I'm sorry. Can you see it clearly here? Okay, can we evaluate the value of the upper limit of this function? We just replace x by the upper limit, right? So it will be pi, and here times 1/3 will be pi over 3. And yeah, we plug in the upper limit first. Yes, it will be 1 cubed minus pi over 5. Very good. Okay, that's it. And we subtract the evaluation of the lower limit. Okay, it will be pi times 1/3 or pi over 3, and 0 cubed minus pi over 5, 0 to the 5th. Okay. Then now they are just numbers. Okay. 0 to the 3 times anything will be 0. This guy is also 0. It's easy. So here, pi is a common factor, so we can factor it out. If we factor pi it out, here inside will be very good. 1/3 minus 1/5 here, right? And these guys are the fraction with different denominator. So our job is to find the common denominator. Okay. And then multiply with the appropriate numbers. So it gives us 5 minus 3, it will be pi and 2/5 here. Okay. That's it. Is it clear? Oh, 15, yes. Thank you. Good job. Yeah. So the difficulty of this section is to write down it clearly, right? The computation is not difficult. So now, let us do the quiz, in-class quiz here. Do you have any question for me? Very good. And one is